We are now going to flip things around. Whereas before we were taking an absolute value equation and solving it, we're now going to try to come up with the absolute value equation. So before we actually do that, though, I want us to still work with giving an absolute value equation and solve it. But I'm going to do so with these top three examples right here. We'll solve them and then also graph the solutions, and seeing the relationship that exists in all of these will really help us understand what we want to be able to do, which is to be able to write absolute value equations. So let's go to the very first one right here. The equation at the top there is that the absolute value of x is equal to 5. Now let's remind ourselves that whenever we see an absolute value means the distance of whatever is inside the absolute value from 0, and since what's inside the absolute value is x, it's the distance of x from 0, and then you'll see that we've got this equal sign, so it is 5 away. So in a complete sentence right there, that's what we're seeing. So the distance of x, of whatever number x is from 0, has to be 5. Okay, so of course the answers to this equation are very simple. X can either be -5 or 5. And so when we graph those two particular solutions, you can see, oh, hey, yeah, that makes sense in terms of solving the equation. It makes sense in terms of how we've written that in a sentence, etc. Okay, let's go to the next one. We want to take a look at all three of these, and then we'll come back and see how all of these are similar in nature. Okay, so I'm going to solve this equation first, and then I'll write it in a sentence form and kind of show you some cool things graphically about what's going on with this one right here. So with this particular equation, we're just absolute valuing the quantity of x minus 2, it equals 3. So of course, that means that x minus 2 has to have value 3 or -3. So then we can set up two different equations right here. Solve both of them, so you got to add 2 to both sides for both equations. It's going to give you an answers of 5 and -1. And then if we plot that on the number line, then we get those two particular solutions. Great. Okay, so I want to now also write this in a sentence sort of form. So you'll see that, and I'll color code this, I guess. So absolute value really means the distance of whatever is contained in the absolute value from 0, and inside the absolute value in this particular case is x minus 2. So how far x minus 2 is away from 0 is 3 away. So if we take that sentence that I just wrote, the distance that x minus 2 is from 0 is 3, then if we start ourselves like at 0, and then we go a distance of 3 away, then we should be able to find where x minus 2 is located. So if I go 3 away from 0, those two places are the places where you're going to be a distance of 3 from 0, and that's going to be where x minus 2 is located, right? So if that's where x minus 2 is located, then there's two places where x can be located. It should be 2 higher than both of those places, right? Since 2 away would move it to the left, and you'll see that then, oh, well, of course, right there has to be a location of x, right? Because if you go down 2, then there's where x minus 2 is, and then if you go down 2, there's where x minus 2 is as well, right? So that just gives you kind of a hopefully more comprehensive understanding of these absolute value equations and how they relate graphically and such. Okay, but keep in mind that the solutions to that equation there are the green dots there. Okay, we're going to come back for that in just a little bit. Okay, last one, I'll just kind of go through this one a little bit more quickly. So this one, you just have x plus 1. You want that to, of course, be 4. But then you also want -4 in the absolute value to be worth x plus 1. Solve both of them, you're going to get 3 and -5 as solutions. And we'll plot both of them. Perfect. Okay, not going to write that in sentence form. So I'm just going to tell you that in all of these different equations, they're all kind of the form where you've got the absolute value of x minus some other number, and then that's equal to some other number. And that's even in the case of this one, because really in the case of this one, you do have x minus 0 to keep it still just x is equal to 5. So what you'll notice is that actually this number right here is actually the number that's kind of in the middle of the two solutions, and then if you go a distance of 5 away from there, that's going to give you your two different answers. And so similarly with this equation right here, it's x minus 2 in absolute value is equal to 3. So if you centered yourself at this positive 2 right here, and then you went a distance of 3 away on both sides of the 2, you can see you get to those two green dots, which were the answers to this equation. The answers were the 5 and the negative 1. And then finally, this one, it's x plus 1 inside, so if I really write it as x minus, then I'd have to think of this number as being a negative 1. So really that negative 1 would be the center of the two dots, and then I don't know why I wrote a negative 4 there. That's not a negative 4. It should be a positive 4. Okay, and then that positive 4 is the distance that you're away from that negative 1. So it turns out that if you've got like 2 points on a number line, in only those 2 points, you can model that kind of using this absolute value sort of model. So what that basically means is I kind of just think of this right here as just kind of being the middle number between the two different numbers, and then this number right here is going to be the distance that you go from that middle dot to an end. We'll call that a different word a little bit later on as we talk about applications of absolute values, but for right now we'll just kind of think about this in terms of graphical interpretations. This just kind of shows you the same sort of thing in summary there. Alright, so what we're asked to do now is finally, as I said at the very beginning here, is we're going to write an absolute value equation. So when we're asked to write an absolute value equation, right, remember when I define an absolute value equation, it's an equation where you've got absolute values, but there has to be a variable contained inside of that. So in all three of these examples that you're seeing here, there's two dots, and we can use that particular model that I just showed you to be able to write an equation that models these given solutions. So you can see these couple of dots are located at the integer coordinates -3 and 3. So what we'll want to identify is where the middle of this is, and the middle of this, of course, is 0. So we can model this with an absolute value equation where we take x minus, and since the distance away from the middle is 3, that there has to be a 3, and then the middle is the number 0, so the 0 goes right there, and that models it. Now, of course, you could write this more simply because x minus 0 is still just going to be x, so this would just kind of be a simpler way. And if you just think about, you know, if you were to actually solve this equation, think about it, what are the answers to that? -3 and 3, right? And that's exactly what's plotted on the number line there, okay? All right, and then, yeah, with this one, I guess, right here, we're going to want to try to find the middle of these two coordinates. Now, you could just count, you know, like 1 in and until you get to the middle, but if you're trying to find the middle, right, like that's how you want to average numbers. And when you average numbers, you add up, you know, all of the numbers and divide by how many there are. So if I want to find the middle of 7 and -3, the midpoint of them, I can just find the average of those coordinates. So that would be taking -3 plus 7 and then divide it by the number of numbers, which there's 2. So you'd have 4 over 2, which is equal to 2. So that should give you the midpoint, and that is indeed the correct middle of them. And then if I find the distance that 2 is from each of the endpoints, it's a distance of 5 away on both sides. So then I can write this absolute value equation to model this, where the value of the variable x minus the middle of 2, that is going to be equal to the distance away from the middle to the endpoint of 5. So that would be it right there, and you'll see that if you were to solve that equation, you would get the solutions of -3 and 7 that we see there. So like if we were to plug in -3, right, you can see that you get -5 inside, the absolute value would be 5, so great. And then if you plugged in 7 in for x, you'd get 7 minus 2, which is 5, and absolute value of 5 is 5. So that works great as well. All right, and then the last one right here, just got to find the middle of the, so what numbers are these? So let's see. Well, that's going to be negative 5.5. And this one's going to be negative 2.5, right? Yeah. Okay, so we want to try to find the middle of those two coordinates. So we can average them. And to average them, you can take negative 5.5, add it with negative 2.5, and then divide by the number of numbers. So it's going to be negative 8 when you add, divide by 2, and you get negative 4 should be the average. So that should be the midpoint of that. And then we also want to know the distance away. So to go from negative 4 to negative 2.5, you're going to have to add 1.5, and then that's 1.5 away as well. So the absolute value equation that's going to model this is going to be x minus the middle. So when you minus the middle here, you're minusing negative 4. So I'll write it that way first, but really, of course, it's going to turn to plus 4. And then the distance away is 1.5. So I'll just kind of turn that into a plus right there. So yeah, it's just going to be the absolute value of x plus 4, and that's going to be equal to 1.5.